Our next last stop on a review of Algebra 1 materials, moving into Algebra 2, is solving inequalities. Now, solving inequalities will share a lot of the same properties, as you can see from this list, as solving equations, with a few minor exceptions as noted by the asterisks. So first, transitive property. Transitive property, when we are dealing with inequalities, same as when we are dealing with equations, states that if A is greater than B, and B is greater than C, then we have to know that A is greater than C. And this is also true if our inequality sign is less than. So, a numerical example of this, if 1 is greater than 2 and 2 is greater than 3, then we can skip the 2 and just say 1 is greater than 3. Next, equality of addition. If I have A is greater than B, then A plus C is greater than B plus C. If we add the same number to both sides of an inequality, the inequality will hold true. So if we have 6 is greater than 2, then 6 plus 4 is greater than 2 plus 4. Simplifying, we get 2 is greater than 6, and that is true. So now, if we were to do this with subtraction, if A is greater than B, then A minus C is greater than B minus C. So if 6 again is greater than 2, then 6 minus 1 is greater than 2 minus 1. Simplifying, we get 5 is greater than 3. Oh, sorry, greater minus this time, greater than 1. Now, equality of multiplication comes in two parts, so I will show those separately. If A is greater than B, then A times C is greater than B times C if C is greater than 0. If C is positive, the inequality will hold the same thing. If A is greater than B, then A times C is going to be less than B times C if C is less than 0. If C is negative, it changes the direction of the inequality sign. Another name in mathematics for negative is the opposite of. So when we do an opposite number with inequalities, we have multiplying or dividing, and we'll get that with the equality of division. Our opposite sign will make it so that we have to have an opposite inequality. And again, same thing is true for division. If A is greater than B, then A divided by C is greater than B divided by C. If C is greater than 0, A is greater than B will give us A over C is less than B over C if C is less than 0. So again, anytime you multiply or divide by a negative number, it will change the direction of your inequality. Let's solve some inequalities and see how this works in practice. Solving inequalities, we end up solving them and graphing the solution. Since our solution is not a single point as it is with an equation, having a visual reference for this field of numbers helps us to see all possible answers or solutions. When you graph with an equal option, you have a filled in circle on your number line. When you have a non-equal option, then you have an empty circle at the place on your number line. So if we have negative 6 times x plus 5 is less than or equal to 92, we're going to solve this the same way we did our equations. We're going to begin by dividing both sides by a negative 6. And that gives us x plus 5. 92 divided by a negative 6. It's going to give us a negative 15 and 1/3. Now, because we divided by a negative sign, we're going to change the direction of our inequality. Now, continuing on, I see addition here, so I'm going to subtract 5 from each side. And I get x is greater than or equal to a negative 20 and 1/3. Now, putting this onto the number line, the most important point for me to have is going to be negative 20 and 1/3. So I'm going to put a negative 21 and a negative 20 and negative 19, and I'll put negative 22 over here. Now at negative 20 and 1/3, I will have a filled in circle because it is equal to, and I want numbers that are greater than that. So I'm looking at everything that falls to the right. Next, negative 7 plus 5w is less than 53. So going through and solving this, I'm going to begin by adding 7 to each side using the addition property of inequalities. I have 5w is less than 60. Next, I will divide both sides by 5. And I come out with w is less than 12. So on my number line, 12 is the most important point. Put a couple others on there so I have reference of where I'm at. And since I'm not equal to this time, I'm going to put an empty circle around where the number 12 is. And I'm looking at everything that would be less than this. So that will be from here going to the left. Okay, so that's basic graphing of inequalities, including solving the equation. Now, when we're dealing with inequalities, we have occasion where multiple things can be happening at one time, and this is called a compound inequalities. Come in two parts. They come in and they come in or. So let's solve one of each and see what the graphs of these ones look like. So we're going to begin. We will have to solve these two inequalities separately. Some compound inequalities, especially the and type, can be solved simultaneously, and we'll get to that in later units. So we're going to begin by subtracting 4 in our first inequality. So I get 2d is less than 19, dividing both sides by 2. I get d is less than 9.5. Next, solving my other side, I'm going to divide both sides by 3. Now here I do not need to change the direction of my inequality because the number I'm dividing by is positive, even though the number that's being divided is negative. So I come out with d is greater than a negative 5. So I have these 2 points, positive 9.5 and a negative 5. D is less than the first but greater than the second. So let's put some numbers on our number line here. And now graphing this inequality, at negative 5 I will have an open circle, which is halfway between the negative 6 and the negative 4. And at positive 9.5 I will have an open circle, so right up by positive 10. And what I'm looking for is all items in between. It has to be greater than the negative 5 and less than the 9.5. So my answers are the things that fall in between these two lines. And that's going to be the nature of your inequalities with and. It has to meet both qualifications at the same time. The lines should be going towards each other as you work. Now let's try that same inequality using or. So I'm going to subtract 4. All my work is going to come out the same as I do this. So in the end I have d is greater than 9.5. Then solving the other side, I'll divide by 3 and I get d is less than a negative 5. So same items, but this time I'm saying or, and my inequality symbols are going in the opposite directions. So putting my numbers back onto my number line and then plotting my points. At negative 5 I have an open circle, and at positive 9.5 I will have an open circle. Then what I need to do is graph the directions, and I'm looking at items that are greater than 9.5 or less than the negative 5. So we end up with an or equation, or an or inequality. You have items that go in opposite directions, and you cannot satisfy both relationships at the same time. That's why it's or. So solving inequalities is going to be very helpful for us as we move forward, and being able to graph one-dimensional inequalities will lead us into graphing two dimensionals later.